So now as we get into how we're interpreting the EKG, it's important to have a very systematic approach. Okay, so we're going to have a couple steps that we follow through every time, whether we're looking at a tele strip or a full 12-lead EKG, and let's get to follow through those steps just to make sure we're not missing anything, right? And depending on where you look online or your book or anything, there might be extra steps thrown in there or taken away. I'm giving you my method here. I encourage you to look up different ones and kind of take an ad from that for what you need in your own practice. Regardless, the first thing I'm going to start with are the three R's. Three R's, okay? And that's going to be our rate, our rhythm, and our regularity. So we're talking about rate, okay? We're talking about our atrial rate and the ventricular rate, okay? So atrial rate and ventricular rate. So that's talking about the rate for our P's, okay, and the rate for the Q's or the R's. So in cases such as like a flutter, for example, where the atrial rate may be like 200, and we might have a ventricular rate that's 100. Okay, so that's one of those things that's the first kind of step in figuring out what's going on. As well, if you have like sinus bradycardia, right, knowing that our ventricular rate is 35 is going to be relevant. The next thing is looking at the rhythm, and when we're talking about rhythm, I'm talking about every P, right, for a Q or a QRS. Okay, and that's going to help us determine whether this rhythm is a junctional rhythm, is it a sinus rhythm, atrial rhythm, ventricular rhythm. Okay, and finally, the last one is regularity, and that's whether our QRS complexes and our P waves are they regular? Are they regular to each other or just to themselves? So, do we have a regular P rate and the QRSs are irregular? Are the QRSs regular and the P's are irregular, etc. When we go there, the next step I always look at, that's kind of separate from these two, is our axis. And the main axis that we're looking at whenever we're talking about that too is going to be the ventricular axis. Okay, we don't worry too much about the atrial axis. The only time we kind of briefly look at that is AVR. Okay, so AVR for atrial. And that is, again, just to help us figure out whether or not this is sinus. If we see something weird that's going on, if the P's are flipped upside down or something, we can look at this a little bit more in depth and figure out whether or not we have a sinus rhythm or if we have an ectopic atrial rhythm. From there we go to our three I's. Okay. And the first one here is going to be our intervals. The next one is going to be for ischemia or infarcts. And the last one I list here is irregularities. Okay, just general irregularities. So an important thing, anything in your practice is knowing what is normal uh, to know what is abnormal. Okay, so we're not always going to know exactly what's going on in the EKG unless you're EP cardiologist or something. Even sometimes they might see something that's out of whack that they don't even know what's going on. It's important to know just that something isn't right. Okay, so if you have something, you go through all these and something still isn't adding up, that's the point. You know, you can ask more questions, bring it to somebody else. With intervals, we want to go count everything out. So we're going to get our rates, right? So we'll get our precise heart rates. We'll get our PR interval, our QT interval, right? And we'll go count those all out with our small boxes, big boxes, and everything. That second one there, the ischemia and infarcts, um, is a way of looking at do we have any ST elevation or pathological Q waves. And that's something whenever we get into ischemia and infarcts that'll actually kind of matter. Until then, just know if you see ST elevation or depression, something's going on as far as ischemia. Okay. So now before we get into fully applying that and looking how we're going to do that for our EKG, we're going to go over how the EKG is kind of set up in the first place, because we have a bunch of different boxes and times and everything. So in general, we're going to have two axes, right? So we have our left to right axis, so it's going to run this way, and that's going to be time. Okay, and time itself on the EKG generally is going to be 25 millimeters per second, and that's in the US. Okay, that's the kind of US standard. If we're in another country, or if you're in an electrophysiology lab, you're going to see a 50 mil per second standard. So it's important whenever you see a 12 lead EKG or anything like that, you check the bottom left hand corner. If you're watching this and you're a nurse, you don't really need to worry about this too much. Majority of them are going to be set to 25 mils per second, especially for telemonitoring. Okay. Now, the other axis that we have up here, going up and down, is where the EKG gets kind of confusing and it has a misnomer. So this is going to be, they say millivolts, but really we want to refer to it as millimeters. Okay. So our up and down here, to start breaking this down, each one of these boxes here, the small box, is going to be 0.1, okay, or 1 millimeter. So we got 1 millimeter, or 0.1 millivolts. Okay. So this big line, these are all broken into fives. Okay. So this big box here is going to have 5 small boxes in it. So that's going to be our 5 millimeters. Okay. So the big box, I'll write this over here to the side. Small box is 1 millimeter. Big box is 5 millimeters. Okay. Now that's another thing that can kind of get wonky whenever we're talking about things, because you'll often see the 1 millivolt, right? And that's going to be these two big boxes together. I generally don't like saying that, just because, again, the EKG isn't actually picking up in it in that way. Okay. And good example of why that's not always right is that if you have, say, telemonitoring or something, and you change the amplitude on this or the gain, you set it to like 2 times so you see things better. This might be up here, right at the top, but that's not necessarily 1 millivolt of energy that's going through it anymore. So that's where things get kind of weird, and I don't like using that. Use the millimeters as opposed to millivolts. Okay. So now if we get to the more important part down below is our time, because this is the one we're going to really care about when we're doing our measurements and everything. And that's where those intervals are going to come in. So again, each of these big boxes, okay, so each big box on this, if we're using the 25 mil per second, we're going to discount from here on out the 50 mil per second. If you're looking at a 50 mil, at that point just divide these by 2. So each big box for time is going to be 0.2 seconds. Okay. Each small box, because this is divided by 5, is going to be the 0.4 seconds. Alright, so each of these small boxes here is the 0.04. Alright. Now, often a lot of these, they're going to be done into a 6-second strip if you're doing telemetry monitoring. One of the methods to doing a heart rate, okay, is to take that 6-second strip, you count however many QRSs are in there, so you look at all these R waves. If this were a full 6-second strip, you take however many QRS complexes are in there, multiply that by 10, so we have a 6-second strip we've turned to 60 seconds, and that gets you a quick heart rate. Okay. The other two methods, my preferred methods, they're a lot more accurate. This is how you're going to do it if you have an actual 12 lead. Is we have a small box method. So small box, and then we have a big box method. Okay. This is for our heart rates over here. And this can be used for atrial or ventricular. It's not going to matter. So with the small box method, we're going to do 1500 divided by the number of small boxes, and that's going to get our rate. If we're using the big box method, we're going to do 300 divided by the number of big boxes, and that's going to get our rate. So now if we do an example here, we'll start with the big box method. Okay, so we have our R wave. So whenever we're measuring this, uh, when we're doing the QRS, the easiest way is to find our peak. If we had a deep S wave, we'd be using the S instead. But with this, we're going to go R, so our peak of R to peak of R. Okay, and we're going to say this is just a half of a big box. At this point, we're just going to round that. So we have half of 1. There's a 1, so we're at 1.5 big boxes, 2.5 big boxes, and we got 3, right? So at this point, we have 3 big boxes. We'll do the 300 over here, divided by the 3, and that gets our heart rate or ventricular rate. Okay, and that's going to equal 100 beats per minute. Okay, so that's a really quick, easy way to do this. We can get more accurate with it if we go ahead, we'll erase this, and we're going to use the small boxes this time. So easiest way to do this, because you don't want to sit here and count 1, 2, 3, 4, 5. I mean, you can, but I think that takes a little bit too much time, is, again, we're going to do the big box. So we're going to skip here. We have 1 big box, and remember that's 5 small boxes that are in there. So 1 big box goes to 5, 2 big boxes, so 5. So we're at 10, 11, 12, 13, 14, 15. Okay, so we have, at that point, it's going to be 1500 divided by 15 small boxes, and that's going to get a heart rate of 100 beats per minute. And now if we want to do the same thing for our atrial rate, we at this point we'd use the beginning of the P wave, okay, and we would count it out just the same. All right. So another little trick here that I like to use, so a couple ways whenever we're counting this. For starters, to make it easiest on you, uh, if you find an R wave, will usually somewhere on the strip line up really well with this line, right? So if we could find one that lines up perfectly well with this line, then we just use the big boxes to count these 5s out. So we go to the next one, so this would be 5, 10, and then we add on, so that's 13. It's a lot easier to do than having to back count or anything. Saves you a bit of time. In the case of this P wave, we see it's 2 right before this big one. So we'll just count out that same way. I'll go 2 before this one. So there's 5, 2 before this one, 10, 2 before this one is the next P wave. And at that point, that's 15. 15, so 100 divided by 15, we get to 100 beats per minute for atrial rate as well. So now knowing this and how we can count everything out and how to get our intervals and everything, we're going to go through and start applying that systematic approach for this. Okay. So if we remember just a second ago, so we had our 3 R's, right? So our rate, okay, we're going to do our rhythm and regularity, right? Then we're going to have our axis, our intervals, ischemia, and irregularity. So we're going to go through for this little strip right here, and we're going to say that this is lead 2. I'm just going to write this here, just to give us something to go off of. So the first thing we have to do is figure out that rate. Luckily we just did. We'll do this again to recap. I'm going to use a small box method. Okay, so again we got 1, 2, and then we can add that on. So 7, 12, 13, 14, 15. So if we do that 1500, right, again divide by 15, we get a rate of 100 beats per minute. So I'm going to break this out into 2. So we have our A rate and our ventricular rate. So the A rate, again, we did just a moment ago, that was 100 beats per minute. And a ventricular rate as well is 100 beats per minute. Okay. So next thing we look at is our rhythm. So does every QRS have a P? Are these attached together? And the answer to that is yes. So if we look here, we see we have a P, and we have a QRS. We have a P, we have a QRS. And this P is upright in lead 2. Okay, so we can say that this is a sinus rhythm. Okay, so we have a sinus rhythm. Then we look at regularity. Is there any irregularity here? We would need a bit more to actually really figure this out. We would go R to R this whole way, P to P this whole way. But we could say in this case, going off of what we do have, that this is regular. Okay, there is total regularity. There's nothing weird going on. There's no weird things popping up. As far as axis, we're going to skip this in this case just because we only have one strip, and you can't figure out the axis from just one lead alone. Okay, so we're just going to little X. So now our intervals are going to be the next thing. So the big ones we want to do, remember, are going to be our PR interval, our QT interval. Okay, so the PR interval, remember, it's going to start from the beginning of the P. It's going to go to the start of the Q. So we just count our small boxes here. So we got 1, 2, 3, and we can round this up because it's right there towards the end. So we'll say 4. So that's 4 small boxes times the 0.04 seconds. So we have a PR interval of 0.16 seconds. Okay. Our QT interval is going to go from the start of the Q to the end of the T, and the end of the T is going right about here. In this case, since this is conveniently along this big line, I'm going to count back this way. So we know we already have 5. Okay, so there's 5 small boxes. 6, 7, and we'll round this here to 8. Okay, so we have 8 small boxes. Multiply that times the 0.04. We get 0.32 seconds. And that's kind of short, but that's just within our means. That's an okay. All right. So both of these are normal. If we need to, we can also go and do our intervals. So our R to R interval, which we already did to get our V rate, and a P to P, which we did to get our A rate. Sometimes you need to do your ST segment and everything. We're not going to cover that in this case. As far as ischemia, we see the ST segment here. So this line, okay, is the important one, is in line with our isoelectric line the entire way. It's not up, it's not down, it's right where it needs to be. And we don't have any abnormal irregularities here, especially in the Q. So we could do none. And irregularity, I don't see anything weird here. It looks normal to me. I don't have any questions, so that is good. So at this point, we've gone through and we've determined that we have a sinus rhythm, a normal sinus rhythm. It's towards the upper end at 100 beats per minute. But that's how we can say we have normal sinus rhythm. Okay. Now, if this were a little bit higher, if that rate was, say, 102 beats per minute, we would say we have sinus tachycardia at that point because we're above that 100 beats per minute.